Hello and welcome to the second of several tutorials on subsets. I hope everyone has already watched video number 8 on pairs, because today we will take the next step up and learn about triplets or triples. As I mentioned earlier, the larger subsets of 4, 5, and 6 will be covered in my advanced series. But today we will focus on triples. So let's go over to the puzzle board and see what these look like and how they work. If you remember from the terminology video, a subset in Sudoku is defined as n number of candidates in n number of cells. Like 2 candidates in 2 cells, or 3 candidates in 3 cells, or 5 candidates in 5 cells, and so on and so forth. And further, the cells and the candidates of the subset must be contained entirely within at least one house, i.e. a row, a column, or a 3x3 block. And don't forget, there is no such thing as a subset of 1. If you have one candidate in one cell, and it is the only occurrence of that candidate in a particular house, even if it is hidden, it will be the solution to that cell, and you need not go any further except to solve that cell for that digit. Okay? In Sudoku, a subset of a triple is defined as 3 candidates in 3 cells that all lie in the same house. Remember that. 3 candidates in 3 cells that all lie in the same house. And just like pairs, these come in 3 varieties: naked, hidden, and locked. A naked triple is one in which the 3 candidates are the only candidates in the 3 cells. A hidden triple is when the 3 candidates are contained in exactly 3 cells of a particular house, but they are camouflaged by the presence of other candidates. And a locked triple is simply a naked triple that lies in 2 houses at the same time. The most important thing to remember about triples is that all 3 candidates do not need to be in all 3 cells. As long as you have at least 2 of the 3 candidates in each one of the 3 cells, then that works just fine. You just need to see 3 candidates in 3 cells in any combination. Now here's why. Okay, here we have a standard naked triple. 3 candidates in 3 cells that all lie in the same house. In this case, row number 1. 769, 769, and 769. In this case, all 3 candidates occur in all 3 cells. So common sense will tell you that those 3 cells have to be solved with a 7, a 6, or a 9, because that's all they can be. But let's prove it by logic. Let's imagine the 3 cases for cell number 1 and see what happens to the other 2 cells. So let's imagine we solve the first cell as a 6. So what happens? The other 2 cells become a naked pair. And we know that in a naked pair, this one has to be the 7 and this one has to be the 9, or this one has to be the 9 and this one has to be a 7. So if the first cell is 6, the other 2 are either 9, 7 or 7, 9. And there you have your 3 digits. So now let's go back and let's imagine that the first cell is a 7. So if the first cell is solved for 7, that leaves a naked pair in the other 2 cells of 6 and 9 and 6 and 9. So this one has to be the 6 and this one has to be the 9, or this one has to be the 9 and that one has to be the 6. So if the first cell is a 7, it's either 7, 6, 9 or 7, 9, 6. And lastly, if the first cell is a 9, then that leaves a naked pair of 7 and 6 and 7 and 6. So it has to be either 7 and 6 or 6 and 7. So there we've proved, we've taken all the possibilities for the first cell, and it shows that these 3 cells have to be 9, 6, and 7. Okay, here's another triplet that lies in a column, column 4. The candidates are 2, 5, and 8. We have 3 candidates in 3 cells, but this time notice that the middle cell only contains the 2 and the 5 and doesn't contain all 3. But as I told you, That doesn't matter as long as you have at least 2 of the 3 candidates in each of the 3 cells. So let's do the same thing again. Let's imagine the first cell is solved for 2. What happens? We get a naked single and a naked single. So that's 2, 5, and 8. Now if the first cell is solved for 5, then we get a naked single and a naked single. 5, 2, and 8. And if the first cell is solved for 8, then we get a naked pair, so we know that it's either 2 and 5, or it's either 5 and 2. So these 3 cells will be solved with the 8, the 5, and the 2 in some combination. All right, here's another naked triple that lies within a block this time. Block number 6. 3 candidates in 3 cells, 1, 3, and 4. And this time, 2 of the cells only have 2 candidates each in them, which is fine. So let's take the 3 cases for the first cell and see what happens. Let's imagine we solve the first cell for 1, we get 2 naked singles. If we solve the first cell for 3, we get a naked single and then another naked single. And if we solve the first cell for 4, we get a naked single down here and a naked single up there. So those 3 cells have to be 1, 3, and 4 in some combination. Okay, here's an example of a triple that has only 2 candidates in each of the 3 cells. Now when this happens, it can only be one way, and I used 1, 2, and 3 here for a reason. Imagine that the candidates are A, B, and C. It has to be AB in one, AC in another, and BC in another. Because if it was any other combination, it would not be a triple. So here we have 1, 2, 1, 3, and 2, 3. 3 candidates in 3 cells. They all lie within one house, row number 3. So now there's only 2 possibilities for this first cell. So let's see what happens. If the first cell is a 1, then we get a 3 and a 2. And if the first cell is a 2, then we get a 3 and a 1. And now let's do the middle cell. If the middle cell is a 1, then we get a 2 and a 3. And if the middle cell is a 3, then we get a 2 over here and a 1 over here. And then for the last cell, if the last cell is a 2, we get a 1 and a 3. And if the last cell is a 3, we get a 1 and a 2. So those 3 cells have to be 1, 2, and 3, even though there are only 2 candidates in each cell. But like I said, it has to be distributed like this: AB, AC, and BC, or else it will not be a triple. Now here is something that at first glance may look like a triple, but it's not. It's 3 candidates in 3 cells in column 5. But upon closer examination, you see that the top cell has a 4 and an 8, and the bottom cell has a 4 and an 8, so that is really a naked pair. And because it's a naked pair, you can eliminate the middle 4 and 8, and the middle cell becomes a naked single for a 2, and then you're left with just a naked pair. So like I said, the distribution is important. It has to be 3 candidates in 3 cells in one house, but they have to be distributed evenly. And if there are only 2 candidates in each of the 3 cells, they must be distributed as AB, AC, and BC, as I showed you a minute ago. Now here, for example, we have 3 candidates in 3 cells, but if you look carefully, they do not lie in the same house. They're spread all over the place. They do not share any house in common, so this is not a triplet. Triplets must be in the same house. You must have 3 cells with 3 candidates that all lie in the same house. Okay? Okay, so now let's see how we can use these naked triples to help us solve the puzzles. In row 1, we see we have 3 candidates in 3 cells: 7, 6, 9, 7, 6, 9, and 7, 6, 9. And we know that when this happens, one of those 3 cells has to be the 7, one has to be the 6, and one has to be the 9, even though we don't know which is which right now. But still, we know that those 3 digits have to go into those 3 cells. So that means 7, 6, and 9 cannot be true in any one of the other cells in row 1, just like with the naked pair. So we can eliminate every 7, 6, and 9 outside of those 3 cells that lie in row 1. So we can eliminate this 7 and this 9 and that 6 and that 9 and that 7 and that 6 and that 6 and that 9, that 6 and that 9 and that 7 and that 6. Because those 3 darker colored cells must contain the 7, 6, and 9, which means they cannot be true in any other cell of that house. Okay? All right, now let's look at a column. And we see we have a triplet of 2, 5, and 8 that lies in 3 cells, although only the 2 and the 5 occur in the middle cell, which is okay. So this means the 2, the 5, and the 8 have to go into those 3 darker colored cells. So we can eliminate 2, 5, and 8 from every other cell in that column that lie outside the colored cells. So we can eliminate this 2 and this 5, this 8, that 2, 5, and 8, that 5, that 2, that 8, and that 2, 5, and 8. Does that make sense? And then lastly, let's take a look at a block. And we see that we have a triplet of 1, 4, and 3 in block 9. And this is the configuration that I showed you earlier, A, B, A, C, and B, C, which is the only way it can be when there are 2 candidates in each of the 3 cells. So this is perfect. So we know those 3 darker colored cells are going to be solved with a 1, a 4, and a 3, although we don't know which is which right now. But still, that means that no other 1, 4, or 3 can exist or be true in the rest of the block. So we can eliminate that 1 and that 4. We can eliminate that 1 and that 3. We can eliminate that 1 and that 4. We can eliminate that 4 and that 3. And that 1, 4, and 3, and that 3. And all those eliminations are possible because we have a naked triple that lies entirely within block 9. Now, hidden triples work just the opposite of naked triples. In a naked triple, the 3 candidates are the only candidates in the 3 cells. That's why they're called naked. And this allows you to eliminate all other instances of those 3 candidates that lie outside those 3 cells. But with a hidden triple, the 3 candidates do not lie anywhere outside of the 3 cells in that house. And that allows you to eliminate any other candidates from within the 3 cells themselves, like this. Here in row 1, we see that the digits 7, 6, and 9 do not appear anywhere else in row 1 except the 3 dark colored squares. This means those 3 cells have to be filled with a 7, 6, and a 9 because they cannot be anywhere else. So that means you can eliminate every other candidate from those 3 cells besides the 7, 6, and 9, like this. You can eliminate the 2, the 4, the 5, and you can eliminate the 3, the 5, and the 8, and you can eliminate the 1, the 2, and the 4. Okay? So let's take a look at the next one. Here in column 2, we see that the digits 2, 5, and 8 only appear in those 3 darker colored cells. And they do not appear anywhere else outside those cells in column 2. So that means those 3 cells have to be solved for those 3 digits because they can't go anywhere else. So that means you can safely eliminate all other candidates from those 3 cells. So you can eliminate the 1, the 7, and the 6. You can eliminate the 7, the 3, 6, and 9. And you can eliminate the 1, the 4, the 6, and the 9. So now let's take a look at a block. Here in block 9, we see that the candidates 1, 4, and 3 only appear in the 3 dark colored cells. They don't appear anywhere else in block 9 except the 3 colored cells. So that means they are a hidden triple. And that further means that we can eliminate every other candidate from those 3 cells besides the 1, the 4, and the 3. So we can eliminate the 7, the 5, and the 8. We can eliminate the 2, the 5, 8, 6, and 9. And we can eliminate the 5, 6, 7, and 8. And once again, you can see that all 3 candidates do not appear in all 3 cells, but they meet all the other rules. Now with a naked triple, the eliminations are made outside of the 3 cells containing the 3 candidates, but in the same house. And the eliminations, if any, are of the other instances of the same digits as the triple itself. With a hidden triple, all the eliminations are made within the 3 cells containing the 3 candidates, and thus the eliminations are of digits other than the digits of the triple. So naked and hidden triples appear quite differently when you are looking for them. And the implications of a locked triple are the same as a naked triple, except they apply to 2 different houses at the same time, which means you can eliminate other instances of the 3 candidates from both houses. Just like locked pairs, locked triples will occur in the intersection of either a row and a block or in the intersection of a column and a block. And as you can see right here, the intersection of row 3 with block 1 are those 3 yellow cells. And because a triple is 3, it's going to fill up all 3 of those cells. So the intersection of a row and a block looks like that. The intersection of a column and a block looks like that. That's the intersection of column 9 with block 6, those 3 yellow cells. And don't forget, the intersection of a row and a column is only 1 cell. So this does not come into play with triples or pairs. So let's see how these locked triples work. Here we have a naked triple in those 3 yellow cells, 769, 769, and 769. And not only do they lie in row 1, but they also lie entirely within block 1. So they're going to affect the rest of row 1 and the rest of block 1. We know that those 3 yellow cells must be filled with a 7, a 6, or a 9. So that means we can eliminate all the 7s, 6s, and 9s from the row. So let's do that. 7, 6, 9, 6, 7, 6, 9, 6, 9, 7, 6, 9, and 7. But now, those 3 cells have to be filled with 7, 6, and 9. Therefore, those 3 candidates cannot appear anywhere else in that block. So we can eliminate the 6 and the 9, the 7 and the 9, the 6 and the 9, the 7 and the 9, the 7 and the 6, and the 7, 6, and 9. So because that locked triple, and the reason it's locked is because it's in 2 houses. So because it lies in 2 houses at the same time, you can make the eliminations from both houses. All right, let's look at the next one. Now here in a column, we have a locked triple of 2, 5, and 8. It's a naked triple, but it's locked because it lies not only in column 2, but it also lies entirely within block 4. So 2, 5, and 8 cannot appear anywhere else outside those yellow cells in both the column and the block. So we can eliminate this 5, the 2 and the 5, the 2 and the 8. Down here we can eliminate the 8, the 2, the 5, and the 2, 5, and 8. Now in the block, we can eliminate the 8, the 5, and the 2, the 2, the 5, and the 8, the 2 and the 8, the 2 and the 5, and the 5 and the 8. As you can see, these locked triples will always lie within 3 adjacent cells that are contained in 2 houses at the same time. So let's take a look at one more. Here we have in row 6, we have a locked triple of 1, 4, and 3 that lies in row 6 and block 5. So we can eliminate 1, 4, and 3 from both the row and the block. So 1, 3, 3, 1, 4, 3, 4, 3, 1, 3, and 1, and 4. Now we go to the block. We can eliminate 4, 1, 3, 4. There's none in there. 1, 3, and I think that's it. So when these lie in two houses at the same time, you'll see that a lot of eliminations can be made. All right, we'll take a look at one more. Here in column 8, we have one of these AB, AC, and BC type triples, where there are only 2 of the 3 candidates in each cell. But still, it's a naked triple, and it's also locked because it lies in 2 houses at the same time. So the candidates are 2, 6, and 8. So from column 8, we can eliminate the 2 and the 6 and the 8, the 8, the 2, the 6, and the 8, and the 8. And then from block 6, we can eliminate 2, 6, 8, 6, 8, 6, 2, 8, 2, 6, 8, and 2, 8. And there you have it. That's what a locked triple looks like. So now let's take a look at some real examples in real puzzles, and we'll go through all 3 types of triples. Okay, first let's take a look at some naked triples. 3 candidates in 3 cells that lie in the same house. And the 3 candidates will be the only candidates in the 3 cells. So here we have one in block 2, 7, 5, and 6. So we can remove 6, 5, 6, 5, 6. Okay, next one. In column 1, we have 1, 2, and 5. So we can eliminate 2, 5, 2, 5, 1, 1, 2, 5. Next, in column 8, we have 7, 4, and 8. So we can remove this 7, the 4, 7, and the 8. Getting the hang of it? All right, next we have in row 8, 4, 7, and 9. So we can eliminate all the other 4s, 7s, and 9s out of row 8. 4, 7, 9, 7, 9, and 7, 9. All right, next one. In row 4, we have 7, 8, 3. So we can remove 7, 8, and 7, 8, and 8. And that's it. Now sometimes you won't find any eliminations, and sometimes you'll find only 1. But you just eliminate what you can and move on. Next one. Now here we have in block 7, we have a naked triple of 7, 3, and 4. So we can remove this 3, this 7, this 3, and this 4. Next one. In column 7, we have 4, 7, and 3. So we look down the column, we have 4, 7, 4, 7, 4, and that's it. Okay, we keep going. In row 8, 7, 5, and 6, here's 7, 5, and 6, 7, 5, and 6, 7, 6. Next one. 7, 2, and 6, naked triple lying in row 6. So we can remove this 7, 6, and 2, and 6 over here. All right, and the last one, we have 1, 6, and 9 that lies in block 6. So we have a 6, and a 1, and a 9, and that's it, leaving a naked pair over here, 7 and 2. Okay, so those are pretty easy and pretty straightforward. I hope you understand those, and let's move on to the hidden triples, which are by far the hardest ones to find. These hidden triples are so hard to see that not only am I going to color the cells, but I'm also going to highlight the candidates to help you see them better. So here we have in column 5, 1, 8, and 6. And they lie in those 3 cells. Those 3 candidates lie in those 3 yellow colored cells, and they do not appear anywhere else outside those 3 yellow cells in column 5. So that means those cells have to be solved with 1, 8, and 6 in some order. So we can eliminate all the other candidates from those 3 cells. So we can eliminate this 9, we can eliminate the 4, the 5, and the 9, and we can eliminate the 2, the 5, and the 9. Does that make sense? All right, next one. Down here in block 8, we have 7, 6, and 9, and they do not appear anywhere else in block 8 besides the 3 yellow cells. So we can eliminate all the other candidates from those cells. 2, 5, and 4, 4 and 5, and the 3. All right, in this puzzle, let's see if you can find the hidden triple. I'll give you a few seconds. All right, I'll give you a clue. It's in block 3. Can you find it? Okay, well, as it turns out, the 3 candidates are 2, 4, and 5, and they lie here, here, and here. And they do not lie in any other cell in that block. So the 2, the 5, the 2, the 4, and the 4, and the 5. Can you see that? 2, 4, and 5. So that means we can eliminate all the other candidates from those cells, which is the 6, the 7, and the 6, and the 7, 6, and 9, leaving just those 3 candidates. All right, next one. In column 6, we have 3, 5, and 8. So we can eliminate the 1, the 7, and the 9. We can eliminate that 4. We can eliminate 4, 7, 6, and 9. Understood? All right, next one. In row 7, we have 1, 7, and 3. So we can remove the 2, the 5, and the 8, and the 2 and the 5. Next one. The candidates 7, 4, and 6 lie in those 3 yellow cells, and they lie nowhere else in block 8. So we can remove the 1, the 3, and the 9, the 1, the 2, and the 3, 1, 2, 3, 5, 9, leaving just the 4, the 6, and the 7. All right, next. Down here in block 7, we have a triple of 7, 2, and 9 that's hidden. They do not appear anywhere else outside the yellow cells, so we can remove all the other candidates from those 3 cells. All right, let's go to the next one. And again, I'm going to let you try to find it. I'll give you a couple seconds. All right, I'll give you a clue. It's in row 6. And the candidates are 1, 6, and 8. Can you see it now? We have 1, 6, 6, 8, and 1, 8. So that allows us to eliminate the 2, the 3, and the 9, the 2, and the 3, and the 3. Okay, next one, in row 5, we have a triple of 8, 3, and 2. And they do not lie anywhere else outside those yellow cells, so we can eliminate all these other candidates from those 3 cells, leaving the 2, the 3, and the 8. Okay, and lastly, we have a hidden triple in column 6 of 2, 5, and 9. So we can remove the 4, the 3, and the 6, the 1, the 3, and the 6, and the 1, the 4, and the 6. And as you can see, this is also locked because it's in block 5 and column 6 at the same time, but there are no further eliminations to be made. And finally, let's take a look at some locked triples. Now the tip-off for these is that they're going to be 3 adjacent cells, and they're going to be either vertical or horizontal, like this or like this. They're not going to be like this because those 3 cells, those diagonal 3 cells, are not contained in 2 houses at the same time. That can't be. So the only way they can be in 2 houses at the same time is if they're horizontal or vertical. Okay? And if they're like this, That could be a naked triple, but that's not going to be a locked triple because they lie in two different blocks. So the tip-off is when you see three in a row, either horizontal or vertical, and they're within a block. And then you know they've got to be in the row or the column, because here, those three have to be in the row, and these three up here have to be in the column. So with that in mind, let's take a look at some puzzles. Here we have a naked triple of 2, 3, and 5, and it is locked because not only is it in row 9, it's also in block 8. So we can remove all the 2s, the 3s, and the 5s from both those houses. So here we can remove the 5 in row 9, and we can remove the 3 over here in row 9. That's it. Okay, now in the block, we can remove the 2, the 2, the 3, and the 3, and the 5, and the 5, and the 5. Okay? All right, let's take a look at the next one. Here we have a naked triple of 2, 3, and 6. It lies in column 7 and block 3. So we can eliminate the 2s, the 3s, and the 6s from the column. And we can eliminate the 2s, the 3s, and the 6s from the block. So there's 2, 2, 3, and 6. These are very easy to see when they come up, but they're not going to be as common as naked triples. Okay, let's take a look at the next one. Here we have a naked triple of 1, 5, and 8 that lies in column 9 and block 9. So we can eliminate the 1 and the 5 and the 8, 8, 8. And in the block, we can eliminate the 1, the 5, and the 8. All right, next one. Here we've got a naked triple of 4, 5, and 3, and it lies in row 9 and block 9. So we can eliminate the 5, the 4, and the 5 from the block. And from the row, we can eliminate 4, 5, 4, 5, 4. All right, next. Here we've got a naked triple of 2, 5, and 6, and this is one of these A, B, A, C, B, C types where there's only 2 candidates in each cell, but nevertheless, that is a naked triple, and it's a locked triple because it's in column 4 and block 2. So going down the column, we can eliminate the 6, the 2, the 5, and the 6, the 2, the 5, and the 6, and in the block, we can eliminate 2, 6, 5, 6. Okay, next one. Here we have another A, B, A, C, B, C type, and it lies in row 3 and block 1. So we can eliminate 4, 5, and 6 from both houses. 5, 4, 5, 6, 4, 6. And in the block, we can eliminate the 4 and the 5 and the 4 and the 6. All right, next one. Here we have a naked triple of 1, 7, and 8 that lies in 2 houses at the same time, row 4 and block 6. So 1, 1, 7, 8 out of the row, and in the block 1, 7, 1, 7, 8, 7, 8, 7, 8. So you can see these are very powerful and eliminate many candidates each time. Okay, here we have one 5, 3, 9 that's in column 3 and block 7. So let's do the column first. 5, 9, 3. So there's 5, 5, 5, 3, 9. And in the block, we can eliminate 5, 3, 5, 9, and 5. Okay, that's it for today. So let's go back outside and finish up. Triples, or triplets, in all 3 varieties are one of the most commonly occurring patterns or solving techniques you will encounter when solving puzzles of any difficulty level. And they will occur at pretty much any stage of solving the puzzle, from the very beginning to the very end. They are not quite as common as pairs, but they are a close second. Naked and locked triples are easy to find. Finding the hidden ones takes some practice, and you have to look a little harder, but over time, you will begin to find them too, I'm sure. Well, that's about it. I hope you understand the logic of how triples work now, and that you will immediately start recognizing and making the numerous eliminations that are frequently produced by both pairs and triples. We've covered enough examples in today's lesson that I don't think there's any need for an adjunct video. So I will see you in video number 10, where we will begin learning about what are called fish, starting with the notorious X-wing pattern. Until then, be well and be happy.